Good evening, everyone, and we are here for the next lecture. And with next lecture, we start the most lengthy part of this chapter. The most lengthy part of this chapter is known as refraction at curved surfaces. So we are following the same blueprint as we did for reflection. We first studied reflection by plane surfaces, then we went on to reflection by mirrors or curved surfaces. We are doing the same thing here. First we have studied refraction at plane surfaces, whether it was one surface or two surface glass slab or two surfaces inclined at an angle, which was prism. We have seen dispersion, we have seen deviation, and now we welcome this curved surfaces. Now remember, we had seen one sign convention. We have seen sign convention for reflection. We will also be seeing sign convention for refraction, and the sign convention for refraction is also same as what we had seen. For example, if I draw a curved surface like this, and remember I am not going to silver it because it is not going to be silvered. This curved surface has this thing which is known as the pole of the curved surface. Pole. So here we might have a different medium. So we normally draw it like this. This has a medium of refractive index mu2, and this is a medium of refractive index mu1. Do we see this? Mu2 is the refracted medium and mu1 is the medium where you have an object placed. So this is your object. Every curved surface will have something known as the center of curvature. Do we understand this? Because most of the curved surfaces that we are going to deal with, they would be either concave or convex. Which one is this? Is this concave or convex? How do I find out what type of curved surface are we dealing with? So we see which side the object is and what is the side facing it. As you can see here, object is here and this is the side which is facing it. Now looking at the side which is facing it, this surface becomes a convex surface. Do we understand this?
Yes, sir.
Okay. Now to understand the sign convention of this, you have to first understand all the distances are measured from
Pole.
all the distances are measured from the pole. That is one thing. So basically you take your pole as the origin. So your pole becomes your origin, this becomes your y-axis, and this becomes your normal x-axis. Now this is the direction of the incident light. Do you see this? Because the object is placed here. So this is the direction of incident light. So everything which is in the direction of incident light, it is taken as positive. Do we understand this?
Yes, sir.
Direction of light, and I hope everyone is writing it. Direction of light is taken as positive. So in this case that I have drawn, if something is on this side, it will be positive of the pole, and if something is here on this side, it will be negative. Do we understand this?
Yes, sir.
Anything above this pole, anything above the pole, above P will be taken as positive. So if I have something which is like this, it will be taken as positive, and something which is going down will be taken as negative. So this is how the sign convention looks like. But here, as we had seen in case of mirrors, that light normally comes from left side. Here the light may come from the right side as well, because light may come from the right side as well. So if it comes from the right side, everything reverses. Do we understand this? If light comes from this side, this direction becomes positive and this direction becomes negative. Do we understand this? So it all depends on from where the light is coming. From where the light is coming determines your positive and negative, though up and down will always remain same. But depending on from where the light is coming, your sign convention may become different at different points. I hope I am making sense in what I am telling you and you are able to understand this. Yes or no?
Yes, sir.
Okay, I will try to show you a snapshot as well of different cases that we might encounter, and please don't get confused when you have these cases, because they are nothing new. Here are the different cases. This is case number 1. Light is coming from the left hand side. This is the pole. This is the center of curvature, and this is the radius of curvature. Do we understand this?
Yes, sir.
In this case, this side is positive, and therefore your radius of curvature is positive. Do we understand this? But
Yes,
if you reverse it and you place the object inside this refractive medium, if light is coming from this side, this direction becomes positive, and hence your radius of curvature becomes negative. Do you understand this? So basically, if light is coming from this side, basically it behaves like a convex surface, but if light is coming from this side, it behaves as concave surface. Do we understand this? So it basically depends on from where the light is falling. Do we understand this? Normally, for a convex surface, the radius of curvature is positive. For a concave surface, the radius of curvature is negative. As you can see here, this surface, light is coming from here. This is a convex surface. Are you getting my point, bacha?
Yes.
This surface, when light is coming from this side, is convex, but the same surface, when light is coming from this side, this is a concave surface. Then same surface becomes concave or convex. Similarly, look at here. If the light comes from here, this side is positive, so everything going in this side is positive. In this case, this R is negative, so basically this is behaving like a concave surface. Do we understand this? This surface behaves like a concave, and this surface behaves like a convex. Are you getting my point of discussion? That here light can come from any side, no matter what side it comes. Depending on that side, you will have your sign convention. Anyone has any doubts on this? This is a yes. That means we understand this.
No, sir.
Anyone understands this, bacha?
Yes, sir.
Everyone just noted this down. You don't have to note down all the 4 things. If you understand it by one diagram, it is good enough. I have just shown you the 4 cases which are possible. You don't have to draw all the 4 cases. You just have to understand. It depends on the surface and from where light is coming on that surface. In very plain terms, if the surface is convex, the radius of curvature would be positive. If the surface is concave, the radius of curvature would be negative. That's it. Please let me know if you have noted it down.
Done, sir.
No, sir.
Take your time, sir. I will wait for everyone to do it, sir. Don't worry.
Done, sir.
Okay, shall we move ahead in life?
Yes, sir.
Okay, now whenever we have refraction by a curved surface, we have something known as
Sir,
the...
can you go to the previous slide once?
What happened? You had already done it, na beta? Okay. Sit. Okay. Wherever you have refraction by a curved surface, we have something which is known as the refraction formula. The refraction formula for this. Refraction formula for a curved surface. Does anyone know what is the refraction formula, bacha? Everyone noted the last thing? The sign convention is done?
Done, sir.
Anyone knows what is the refraction formula for refraction through a curved surface? The refraction formula looks like this. Mu2 minus mu1 divided by r will be equal to, can you complete it? Can anyone complete it? Mu2 minus mu1 divided by r will be equal to mu2 by v minus mu1 by u. Now what do you mean by mu2, mu1, v and u? Anyone? If I have this as my refracting surface, this is my refracting surface. My object is placed here. Wherever the object is placed, that medium becomes your first medium. Do we understand this?
Yes, sir.
Yes or no?
Yes, sir.
This is my pole. Now the image of this object will be formed on the other side. This is the image I. I'm just drawing a general diagram. The image may not be here. It may be somewhere else. It may be on the same side as well, depending on whether it's real or virtual. I'm just drawing a representative diagram. So the image is formed after refraction. That medium is known as medium with refractive index mu2. Do we understand this? This, my dear friend, is a concave surface. It will have some radius of curvature. Will this radius of curvature be positive or negative? Object is here.
Negative.
It will be negative. Now, look at this. This is the distance of the object from the pole P of the mirror. That is your U. It is same as what we did in reflection. This is the distance of the image from the pole P of the mirror. That is V. These are the meaning of the terms that you see. Mu2 is the second medium, refracted medium. Mu1 is the first medium in which the light is coming from, incident medium. U is the distance of object from the pole P of the mirror. V is the distance of the image from the pole P of the mirror. O is the object. I is the image. And this formula has to be used with what? This formula, whatever formula we understand, it has to be used with proper sign convention. Do we understand this?
Yes, sir.
Proper sign convention. The example that I have given, can you tell me in this example, is U positive or negative?
Negative.
U is negative. The answer for V will automatically come, but whatever V I have drawn, is this V positive or negative?
Positive.
Positive.
V would be positive. Well done. What about R? The radius of curvature of this surface. In the diagram that I have shown, is it positive or negative?
Negative, sir.
It is negative. Do we understand this? This is how you have to solve any question that comes in this particular topic. Do we understand this? Please note down the formula, then I will give you a question to get started with. And remember, these questions, the question that I'm going to give has come in your JEE. So we'll begin by the question, and I hope that you can give me the answer for that question.
Completed, sir.
Okay. Let me give all of you a fair chance of completing. Sometime someone from this class will complete it earlier. Someone from the other class will complete it earlier in the next case. I will have to be fair one. I am the most unbiased person in the entire universe that you will find. Okay, so everyone has done this?
Done, sir.
Sir.
This is the question that is going to come, and I hope that I get the answer in a flash. In a thin spherical bowl of radius of curvature 10 centimeters, filled with water of refractive index 4/3, outside obviously is air, is not mentioned, but you have to take it as air. This is water, refractive index is given. There is a fish which is at a distance of 4 centimeters from the center as shown in the figure. Where will the image of fish appear as seen from E? I'm watching this. Obviously, I can watch it from the other side. We'll also do that one. But the question tells us, if I watch it from this point E, we'll do the other point as well so that the concept is clear. Can I have your answers, please? I'll give you 2 minutes. Don't worry, I'll give you time. I need you to concentrate and get accustomed with the formula. 2 minutes you have. Yes, bacha. Anyone has an answer?
Wait a minute.
I'm waiting. Don't worry. Shall I do it for you? Acha?
5.2, sir.
5.2, sir. Is it a question, sir, or is it an answer, sir?
Answer.
5.2 plus minus multiply divide what? 5.2 where? Inside, outside? Tell me everything, bacha.
Minus 5.2.
Minus 5.2. Minus 5.2. That is correct. My dear friends, minus 5.2. Now let us, I'll draw the representative diagram that is going to tell me. Okay, everyone has done this? Shall I continue on my thing?
Yes, sir.
Okay, this is my object. Oops, wrong color. This is my object O. The distance of the object from the center of curvature is 4 centimeter, but I don't want that distance, right? I am watching it from here. From here. So this is my pole of the refracting surface. Yes or no? So I have to find out U from this point. So what is the distance of this? Because I'm watching it from here, from this side, from the side of E. What is the object distance, my dear friends?
6.
6. Object is placed in water. So 4/3 is where the object is placed. So 4/3 becomes your mu1. We understand this?
Yes, sir.
Yes, sir.
Mu2 is where from I'm watching is the refracted medium. So mu2 becomes 1. Yes or no?
Yes, sir.
If I understand this, then I am okay to solve it. Now I can write the formula mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. Remember, I have to put everything with proper sign convention. Let us start. Mu2 is 1 divided by V. I don't know where V is. So V is V minus mu1 is 4/3. Yes or no?
Yes, sir.
What about U? Is it positive or negative?
Negative.
It is -6. We all understand this? Raise hands will give me more confidence that we understand this. Everyone? Okay. That will be equal to mu2 is 1 minus mu1 is 4/3 divided by R. How much is radius of curvature of this surface, bacha?
10 centimeters.
Plus or minus 10, bacha?
Minus 10.
Minus 10 because this is concave. Do we understand this?
Yes, sir.
Yes, sir.
You put these values and you will end up with an answer. What is the answer that you are getting? I think you are getting minus 5.2 centimeters. Yes or no?
Yes, sir.
That means now you can understand where the image is going to be. Image is 5.2 meter on this side. So somewhere here, the image is formed. And this distance is coming as 5.2 centimeters. Do we understand this? Yes or no?
Yes, sir.
No or yes?
Yes, sir.
Yes, sir.
Everyone got this? Now, just to make a point, if I am watching it from this side, from the point F, can you now tell me what is going to be the answer? From the point F, my dear friends. From the point F. This is from the point E. From the point F. From the point F. Anyone has noted this down? Yes or no?
Noting, sir.
Yes, sir.
Okay, note down. First note it down. Then try it for the next case from point F. I'll give you time. This thing is probably new and will take some time to get used to it. I'll give you 2 minutes. Note it down and try the next one. Yes, my dear friend, anyone got any answer for the second part? Need more time? Okay.
Yes, sir.
Plus 17 centimeters.
Sir, plus 5.2 centimeters.
5.2, I don't think is correct, beta. Somewhere around 16, I think the answer is.
Plus 17 centimeters.
It's definitely not plus. It's definitely not plus. I can assure you that. Shall I do it for you?
Sir, minus 16.6.
Minus 16.15 is the answer that I have with me. If you're getting somewhere around that number, that is good. Shall I do it for you now? Let us start. This is the object. This is the object. Object is placed in water, so mu1 is still 4/3. The other side is air. So my mu2 is 1. Do we understand this, bacha?
Yes, sir.
Yes, sir.
Now I have to find out the object distance. The object distance is now this one. How much is that?
14.
This is definitely 14. 10 is from F to C. From C to O is 4. So this is 14. That's it. Now I can put my formula. My formula is again mu2 by V minus mu1 by U shall be equal to mu2 minus mu1 divided by R. I just have to put all the values. Mu2 is V. Mu2 is 1 divided by V. Everyone can hear me? Yes or no?
Yes, sir.
Minus mu1 is 4/3 divided by U. What is the value of U? Tell me with sign.
Minus 14.
Minus 14. That is correct. That will be equal to mu2. Mu2 is 1 minus mu1 is 4/3. What is the value of R, my dear friends?
Minus 10.
It is still minus 10. Object is here. The rays are coming like this. It is a concave surface. Yes or no? We understand this.
Yes, sir.
If you are going to solve it, my dear friends, I think you will get somewhere around minus 6.1, something of that nature. That should be the answer. I only have the answer, so that should be the answer. Do we get this?
Yes, sir.
Yes, sir.
Everyone, now please check what you were doing differently and why you were doing it so that you understand not to do what and to do what. I'll give you 1 minute, 2 minutes to understand it, because then the next question is coming up. So let me know once you are done writing with this so that I can move ahead with the next question.
Completed, sir.
What about the other class? Have we done this?
No. Not completed, sir.
Okay, I'll wait, don't worry. Once you are done, please let me know so that I can give you the next question.
Done, sir.
Done, sir? Everyone, sir? I
Yes, sir.
hope that you should be able to solve this one and give me a stunning and a correct answer for this one. So here it comes. An air bubble is in glass whose refractive index is 1.5. is situated at a distance of 3 centimeter from a spherical surface of diameter. Remember, diameter is given 10 centimeters as shown in the figure. At what distance from the surface will the bubble appear if number A, the surface is convex, number B, the surface is concave? Which is case A and which is case B? The object is placed in both cases here. So which one is the convex case and which one is the concave
First
case?
one is concave.
First one is concave and the second one is convex. Do you
Convex.
understand this, bacha?
Yes, sir.
Okay. So here it is, and I hope you can give me an answer straight away. Two minutes you will have. Shall I help you, bacha? Shall I solve one for you? You can do the other one. Is that so?
No, sir. Wait, sir.
Okay, sir.
Minus 2.5, sir. Sir,
Minus 2.5, sir.
minus 2.5, sir.
Okay, I have the answer in the first case, I guess. That is correct. Minus 2.5. Can I have the answer in the second case also? Minus 2.5 is correct. The answer for the first case is correct. Well done. Can I have the answer for the second case? Then I'll solve both the cases together.
Minus 1.6.
Well done. Minus 1.6 for the second case is the correct answer. Did everyone get this? Yes or no? This is a yes. This is a no. This is a we did not try. We were sleeping. Got the answer? Shall I do it?
Yes, sir.
Okay. In the first case, I applied the formula mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. What is the value of mu2? What is the value of mu2? Mu2 is the refracted medium, so it has to be air. So mu2 is 1 divided by v minus the incident medium. What is the incident medium? Incident medium is the glass. Yes or no?
Yes, sir.
The refractive index of glass is given as 3 by 2. So I'll write it as 3 by 2 divided by u, the object distance from the pole of the mirror. How much is that, my dear friends? It is minus 3. Yes or no?
Yes, sir.
That will be equal to 1 minus 3 by 2 divided by radius of curvature. What is the radius of curvature of this surface, my dear friends? This one.
Minus 5.
Minus 5. You put the values and you will end up with the answer, and the answer that I have is minus 2.5 centimeters. And that is the answer I think is the correct one. How many of you got this? Please raise your hands. Congratulations. Welcome to refraction at a curved surface. Let us now move on to the second one. I apply the same formula. Formula does not change. Mu2 by v. Why do I write it so many times? So that I remember it and see, I made a mistake. Mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r, and I now put the values again. The value of mu2 is 1, value of v is v minus mu1. See, I'm written 4 by 3 again. The value of mu1 is 3 by 2 divided by, what is the value of u? Has it changed?
Minus 3.
It is still minus 3. That will be equal to 1 minus 3 by 2. What is the value of r now? This surface.
Plus 5, sir.
Plus 5, and that is the difference between this question. Here it is plus 5, there it was minus 5. You put the values, get the answer. I think the answer that you will get is minus 1.6 something, right? 66 to be very exact. That is the answer that is given to me. And that is how you have to solve it. Everyone got this? Yes or no?
Yes, sir.
So this is how you find out refraction from a curved surface. Anyone understand this?
Yes, sir.
Yes, sir.
Okay. Now sometimes right now whatever questions we have done, they were point objects. Now sometimes you can have erect objects. Sometimes you can have erect objects. Now if you have erect objects, apart from asking you where the image is formed, they can also ask you what is the magnification. They can also ask you what is the magnification. So let us now see the formula for magnification by a curved surface. So write the next heading, lateral magnification. This is known as lateral magnification. Anyone knows the formula? Lateral magnification. Anyone knows the formula, my dear friend? Please raise your hands and tell me. Lateral magnification, M, the formula for lateral magnification by a curved surface, refraction. Yes. It is always equal to height of the image divided by the height of the object. Yes or no?
Yes, sir.
Magnification is always like that. And what does the formula come? It comes like this. V divided by mu2 divided by u divided by mu1. So either you can remember it this way or you can remember it this way. Mu1 times v divided by mu2 times u. Remember, the formula is with proper sign convention. V and U must be used with proper sign convention. If the magnification turns out to be negative, then it is a real image. If the magnification turns out to be positive, it is a virtual image. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone noted down this formula, because after this formula comes a small problem. I think this problem is from your module. Do you have your modules with you? Yes or no? No, yes.
No, sir.
Where are your modules?
In the other class.
In the other class. What are they doing in the other class? You are here in this class and your modules are in the other class. Well, that is not a good sign. Anyways, whenever you come to the class, you bring everything with you, because if the modules are in the other class and you are in this class, modules are not going to be of much use. Yes or no?
Yes, sir.
Yes, sir. I'll tell you a small story, sir, what my grandmother, Nani, used to tell me. And he used to tell me in Hindi, and I'll just translate into English, that books don't give us milk when they are sitting at home. हिंदी में किताबें घर पे बैठ के दूध नहीं देती हैं. You don't get milk out of your books when they are sitting at home. Similarly, you don't get milk out of your books when your books are in the other class and you are sitting in this class. Books are only useful when those books are brought in the class in which you are sitting and doing the problems. Yes or no? That is what books are for. Books are not to give us milk. Cow gives us milk. My small child, he was just now, he was having the exam of EVS, and in that he said, sir, cow gives us milk, and not books. Books don't give us milk. So if you want to use your books, please bring them with you to the class in which you are present and studying, not in the other class and the book is studying on its own. Book does not study on its own. Fact number 1. Fact number 2, book does not give us milk, and the light has gone. So remember these 2 facts, okay? Welcome back, everyone. This is the question that we are
Continue
going
the
to
class.
Yes, this is the question that we are going to do. We have an object, as you can see, of height 1 mm. The observer is in air. The radius of curvature of the surface is 20 centimeters. Refractive index is mu, and the distance of the object from the pole, which is A, is given as 30. You have to tell me what is the position, size, and nature of the image. I hope you can do this. Yes or no? You can solve this one for me. Please let me know.
Sir, plus 0.85.
Plus 0.85. What is that plus 0.85? That is the position of the image. What?
Magnification, sir.
No, I don't think that is the correct answer, beta. I don't think that is the correct answer. Have you put the values correctly? I'll give you 2 more minutes to do this. Yes, beta.
Position is 60 centimeters. Height of image is 0.4 centimeters. Virtual image.
Okay, 0.4 centimeters, or I can call it as 4 mm. Yes or no? That seems like correct. I'll give everyone one more chance to solve this. One more chance to solve this. 2 minutes. I want everyone to solve this, basically. Has everyone tried? Shall I solve it? Now again,
Yes, sir.
we apply the formula mu2 by v minus mu1 by u. That was be equal to mu2 minus mu1 by r. Do we understand this? Yes or no? I put the values. What is the value of mu2? Tell me, fatafat. Mu2. mu2 is where observer is, from where you are observing. What is the value of mu2?
1.
Well done. 1. 1 divided by v minus what is the value of mu1? Mu1 is where the object is. Object is
1.
here. What is the value of mu1? What is the value of mu1? It is 2. Yes or no?
2.
Well done. What is the value of
2,
u?
sir.
U. It is minus 30. Yes or no? Do we understand this? Yes or
Minus
no?
30 centimeters.
Minus 30. Yes or no?
Yes, sir.
And mu2 is 1. Mu1 is 2 divided by radius of curvature, my dear friends. How much is the radius of curvature? Radius of curvature, yes. Minus 20, yes or no?
Minus 20 centimeters.
Well done, my dear friends. From here, you will get the value of V. And I think you will get the value of V as minus 60 centimeters. Yes or no, my dear friends? Everyone getting my voice? Yes or no?
Yes, sir.
Okay, that is the first part. What is the second part? I have to find the magnification. Yes or no? Magnification will be mu1 times V divided by mu2 times U with proper signs. Let me put the values. The value of mu1 is 2. 2 multiplied by minus 60 divided by mu2. Mu2 is 1 multiplied by minus 30. That is your magnification, my dear friend. It is coming as 4. Yes or no? So the height of the image will be 4 mm. Is it real image or is it virtual image, my dear friends? Is it real image or is it virtual image, my dear friends? Are you getting my voice, bacha?
Yes, sir.
Is it real image or is it virtual image, bacha?
Virtual image, sir.
Well done, because the magnification is coming as positive. The height of the image is coming as positive. That means the height of the image. The image is erect. Yes or no? No, yes.
Yes, sir.
The image is erect and therefore the image is virtual. Everyone got this? Yes or no?
Yes, sir.
Okay, so we have done this refraction at curved surfaces. Now we can note some important points. Are we ready to note that important points? Are we ready to note that important points? Everyone has noted down the answer and the solution of the previous question. Yes or no? Everyone has noted down the answer and solution of the previous question. Yes or no, my dear friends?
No, sir.
Do you want me to show you that again?
Yes, sir.
So 1.
Yes, beta. Okay. Okay, I'll give you 2 minutes when you are done. Since I've kept all the cameras off, I can't see you. So please let me know once you are done. Please tell me that you are done. Okay?
Okay, sir.
Completed, sir. Completed, sir.
Done, sir.
Everyone has done this?
Yes, sir.
Okay, then let us move and write some important points about this. Important point number 1. We have seen the formula for refraction at curved surfaces, right? What is the formula for refraction at curved surfaces? Can you repeat it so that I can write it? It is mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Yes or no? We understand this?
Yes, sir.
Now from here we can also derive the formula for refraction at plane surfaces. We can also understand or derive the formula for refraction at plane surfaces from this original formula. How can I derive the formula for refraction at plane surfaces from this one, bacha? For plane surfaces, I will write the radius of curvature as infinite because it is plane. That means the radius of curvature is very high. Do we understand this? Yes or no?
Yes, sir.
Yes, sir.
Then how does the formula look like, bacha? It looks like mu2 by V minus mu1 by U will be equal to 0. Yes or no? This is how the formula looks like
Yes,
then.
sir.
Yes or no? Or you can write it
Yes,
as
sir.
mu2 by V is equal to mu1 by U. Yes or no?
Yes, sir.
Or you can write V equal to U multiplied by mu2 divided by mu1. That takes me to the chapter on refraction by plane surfaces, and let me show you that form if I can show it to you. If it's there in this sheet only, let me take you back. If I can take you back, how much back? To take you back, more back. It's quite a bit back, but I hope I can make you see this formula. Do you see this formula that has come on your screen now? Do you remember this real depth and apparent depth is equal to mu1 by mu2? Do you see this?
Yes, sir.
Real depth and apparent depth. This real depth is nothing but actually your u, the distance of the object. This apparent depth is nothing but your v. Do we understand this?
Yes, sir.
Yes, sir.
This real depth is your u and this apparent depth is your v. Now if I take you back in the present, and I have to do it faster because the present is quite ahead of the past, this formula can be understood in that way also, and this is how I remember it. I don't remember it in terms of real and apparent depth. I always remember it in terms of this one. So you can see, my dear friends, I take you back in the present. V is your apparent depth. Do we understand this? U is your real depth into mu2 divided by mu1. So this is the way you can remember any formula for plane surface from the formula on the curved surface. Do we understand this, bacha?
Yes, sir.
Apparent depth is what we see on the refracted side. Real depth is what we see. What is the actual depth or the object distance from the surface? We understand this?
Yes.
Okay, I'll give you 2 minutes to note this down. Once you are done, please let me know.
Done, sir.
Okay, let us wait for the second class.
No, sir. Just wait for a minute. Done, sir.
Okay. Then we shall move ahead and write again some important points which you will not find in books. So please note them down. They might come as a straightforward question, or they might ask you in a JEE Advanced in a different way. So please note down this. Now, whenever we talk about refraction or spherical surfaces, we will have, when we talked about mirrors, a mirror had a focus, yes or no? Do we remember mirror?
Yes,
And
sir.
do we remember focus of a mirror? What was the focus of a mirror? Whether you talk about the concave mirror or the convex mirror, can you tell me what was the focus of the mirror? It only had one focus. Concave mirror or convex mirror had one focus, yes or no?
Yes, sir.
Okay, it had one focus. What was that focus? How did you define that focus? Do you remember what was the focus of a concave mirror or a convex mirror, bacha? Do you say yes or you say no?
Focal length of
Yes. What was the focus?
focal length of the mirror.
Focus was the focal length of the mirror. Does it make sense? Focus was the focal length of the mirror. Does it make sense, beta?
Yes, sir.
No, it does not make sense to me at least, beta. Focus was the focal length of the mirror. That was not the way focus was defined. Can you tell me how was the focus defined? Anyone could try? Yes? No one? Okay. So here we have the focus of a refracting surface. For a spherical surface, a spherical surface has two principal focus. The first focus is known as the first focus, and the second one is known as the second focus. And what is the first focus? The first focus is the point where if you place an object, the first focus is the point where you place an object, the image is formed at infinity. Does it remind you anything about the mirror? The focus of the mirror. Does it remind you anything about the focus of the mirror? Yes or no? If a ray of light passes through the focus, it becomes parallel.
Yes,
So
sir.
focus is the point.
Yes, sir.
From where. Do we understand this? Focus is not the focal length of the mirror. Yes or no? We understand it, bacha?
Sir.
Focus is not the focal length, and this is how it is defined. Yes or no? Do you see my screen? Yes or no?
Yes, sir.
So we said that if a ray of light is
Yes,
parallel,
sir.
we
Yes,
said
sir.
that if a ray of light is parallel, after passing through, after reflection, it will pass through one point that is known as the focus of the mirror. Or we said in the reverse way, we said that if a ray of light passes through focus, it will become parallel after reflection. That was just one point here. In case of a spherical surface, we have two focus. The first focus is the point where you place the object. The image is formed at infinity. How do you find out the focal length? You can remember this formula. What I have done in this formula is that we have put the value of v as infinity and the value of u as minus f. Do we understand this? Or f? Do we understand
Yes,
this? So
Yes,
from
sir.
there, you find out the value of focal length and it will automatically come out to be negative, and this is the value of the focal length that you get. That is known as the first principal focal length, f1. Everyone understands this? Yes or no? Can I have some raised voices? That we understand this, sir. If you place an object at the first principal focus, the image is formed at infinity. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note it down. This is the first principal focus of any refracting surface. You will not find it anywhere else. You just note it down. With the diagram, my dear friend. With the diagram. I hope diagram is self-explanatory. Yes or no, my dear friends?
Yes, sir.
Well done, sir. I'm really proud of you, sir, that you can remember a lot of things, sir. Now, if this is the, have you noted down the first principal focus, my dear friends? Please let me know when you have done.
No, sir.
I'll give you time, sir.
Done, sir.
Let us wait for the other class, sir.
No, sir, not done.
I wait, don't worry.
Completed, sir.
Other class, have you done this, beta?
Done, sir.
Okay then, sir. If that was the first principal focus, what will be the second principal focus? Can anyone tell me? What will be the second principal focus? Can anyone tell me? The second principal focus is this point. When the rays of light are coming parallel to the principal axis, after refraction, they will meet at one point. That point is known as the second principal focus. So what I have done here in the actual formula of mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. That was the original formula. What I have done there is I have put u as infinity and I have put v as f, f2. Do we understand this?
Yes, sir.
And we get this formula for the second principal focus. The first principal focus was minus mu1r upon mu2 minus mu1. The second principal focus is mu2r upon mu2 minus mu1. As you can see, both the focus or focal length are not same. Do we understand this? They are in fact in a ratio, and you can remember this shortcut because they might ask you this. What is the ratio of the two focal lengths? And the answer is very simple. And what is the answer? What is the ratio of the two focal lengths? f1 by f2. The first focal length divided by the second focal length will always be equal to minus mu1 by mu2. I have not seen any question come in the recent time based on this, but you never know. You may have a question based on the first and the second focus. Remember, this first and the second focus will again come in lenses. In lenses, we will be seeing what is the first focus and what is the second focus. Then don't get confused, because for any refracting surface, for any refracting spherical surface, we always have two focus. The first focus is the point where if you place the object, the rays become parallel after refraction. The second focus is the point where rays after refraction, which are parallel, they will converge. Do we understand this? Yes or no? I'll give you
Yes,
I'll
sir.
give you 2 minutes to note this down, bacha.
Completed, sir. Sir.
Well done, bacha. The other class, have we done this?
Yes, sir.
Okay, then that brings us to an end for this class. We have started with the curved surfaces, spherical surfaces. We have covered some problems in the spherical surfaces, and we have seen the sign convention. We have seen the formula for magnification. We have also seen the focal length, the first and the second focus of a curved surface. Will you remember it now, beta?
Yes, sir.
Yes,
Okay,
sir.
then we will continue with the same topic in the next class. In the next class, we'll be starting with lenses. When you come to the next class, please go through what we have done in the previous class, this class, and I hope that the current does not play spoil sport and it remains throughout the next class. I'll see you in the next class. Take care. Have a nice day. Bye bye, beta.
Sir,
Yes, beta.
sir, when